Hi guys. I want to do a few examples of a problem that's like one of your homework problems, as well as a problem that shows up on quizzes and exams. I thought that this problem was presented in the Math 136 YouTube channel videos, but it looks like I was mistaken. So I apologize that I didn't cover this more thoroughly in class. The problem here is to rationalize the denominator. Here we have a denominator here that's got a square root expressions, and there are going to be times where we don't want to have a square root expression in the denominator. The, I guess, conceptual foundation for the process that we're doing is related to a thing called conjugates, which I believe I did talk about in class, but just to reiterate what conjugates are. The expression a minus b is the conjugate of the expression a plus b. So these two expressions are conjugate, and each is the conjugate of the other. That's kind of the way that the language is used. And the way that we're going to be using conjugates have the property that when you take an expression and multiply by its conjugate expression, this is the difference of squares formula, basically. And so we're going to be abusing is maybe a strong. We're going to be using this property not only in problems involving square roots, but as you'll see in the next week, we're going to be using it when we have complex expressions as well, to get rid of the imaginary unit. Okay, and so in this case, when we're going to rationalize the denominator, if we want to effectively remove square roots from the denominator, and we can use the conjugate expression here. If I multiply on top and bottom by the conjugate of the bottom, here the bottom, the original bottom is root t plus 7. Its conjugate is root t minus 7. Now if I want to get an equivalent expression, I have to multiply by the same thing on top. Now on the bottom, we're going to go ahead and take this nice and slowly. When I FOIL at the bottom, when I multiply the first, I get root t squared. When I multiply the outside, that's minus 7 root t. We multiply the inside, that's plus 7 root t. And then the last is minus 49. We will do something similar on top. The first, when I multiply the first pair, I get root t squared. The outside is minus 7 root t. The inside is also minus 7 root t. And then the last is negative 7 times negative 7 is plus 49. Now the top simplifies when I do square root of t squared. Remember, when I do the root and then the power, that works out exactly the way that we want it. So that's just t. When I combine like terms, those middle terms are like terms. They both have a root t. So that gives me minus 14 root t plus 49. And in the denominator, our middle terms cancel out. The plus 7 root t and the minus 7 root t cancel out. So we're just left with t minus 49 on the bottom. And that's all the further we can simplify this. Okay, so notice now our denominator has no square roots in it, and I guess we're happy about that. Thing is we're not always worried about rationalizing the denominator. Sometimes we want to rationalize the numerator for whatever reason. Okay, so here's a problem that asks us to rationalize the numerator. So we have some square roots in the numerator, and maybe we don't want square roots in the numerator. So if we multiply by the conjugate of the numerator here, that would be root b minus root c. That's again the conjugate of the numerator. And we got to multiply on top and bottom by the same thing. Effectively, we're multiplying by 1. So we're not changing the meaning of the expression. Now, here's where, I'm in the last problem I foiled things out nice and slowly, but this business of multiplying by conjugates, it works out the same every time. Remember, we're kind of exploiting we're exploiting this difference of squares formula. Except for I guess we're doing it kind of in reverse. At least that's the way I think of it. This was listed as one of your special product formulas as well when we covered multiplying polynomials on that first day of class. So I guess you could say we're exploiting that product formula. Anyways, here I get root b squared minus root c, not root 6, root c squared. Okay, again, if you're having trouble making this leap, foil it out, and see that just like up here, when I multiply the thing by its conjugate, the middle terms cancel out. All right, that's what's going on, but it's okay if you're quicker than that. On the bottom, I'm not going to actually foil out anything on the bottom. We're going to do something else here in the next step. So I'm just going to write the bottom as b squared minus c squared times root b minus root c. All right, so the numerator just becomes b minus c. This b squared minus c squared that I have in the denominator, I can factor that as a difference of squares. I can factor that into b minus c times b plus c. And then we also have this root b minus root c in the denominator as well. And now I can write my numerator as a product of b minus c and 1. And I have a common factor on top and bottom that I can cancel. And so our final answer here in the denominator, we're going to have b plus c times root b minus root c. And in the numerator, we just have 1. Okay, so we've successfully rationalized the numerator. Now our numerator is just 1. There's no square roots left in the numerator. Now we do have square roots left in the denominator. We're always going to have square roots left somewhere. We can't completely get rid of them, unless we're super duper lucky, but usually we're not going to be able to completely get rid of them. All right, so that's it for that problem. Moving on to maybe a slightly more challenging problem. We want to rationalize the denominator once again. So our denominator involves some square root expressions that maybe we don't want there for one reason or another. So if we want to multiply by the conjugate here is 2 root x plus root y. And again, we're going to multiply on top and bottom by the same expression. On the bottom, when I FOIL this all out and take a couple steps to do that, if you need to, you should get 4x minus y. Please, if you don't see that immediately, please take time to fill in the steps there. Okay? On top, again, I'm not gonna distribute this 2 root x plus root y through, but I am gonna factor. This is a difference of squares. I can write this as 4x squared minus y squared. So that's a difference of squares. I can factor it into 4x minus y times 4x plus y. And again, if I write my denominator now as the product of 4x minus y and 1, I have common factors on top and bottom that I can cancel. So that was convenient. And now we just have a fraction over 1. So we did even better than rationalizing the denominator. We made the denominator 1. Okay, so here's my final answer for that one. So that one was a step up. That one was a step up from some previous problems in the sense that we have a more complicated binomial that we were trying to rationalize by finding its conjugate. This last problem is a good challenge. Okay, it can involve several ideas from this section. We have a complex fraction that involves some square roots. So we're going to get to practice our strategies for dealing with complex fractions as well as square roots. You guys know I love doing problems from the calculus course. and this is an algebra problem that would show up in the context of a calculus problem. All right, so those of you who are not moving on to calculus, you may never have to worry about anything this complicated. And you can feel free to stop the video now. You have my permission to not watch. Those of you who are going to end up moving on to calculus, you will most likely have to do a problem like this in the context of a larger problem. So you should maybe hang on and check it out. All right, so the first thing that we're going to do is deal with the complex fraction part of this. We're going to multiply on top and bottom. Oops, I don't want green. We're going to multiply on top and bottom by a common denominator. Actually, only the numerator has denominators. So the common denominator of all the denominators that show up is root x times root x plus h. And we're going to multiply on top and bottom by that. Again, here, we're not doing any rationalizing of anything yet. This is just dealing with the complex fractions part of the problem. Okay? Now, when you distribute this through on top, okay, the root x plus h part cancels out in the first bit, and you're just left with root x. And the root x bits cancel out on the second term. When I distribute this onto the second term, the root x here cancels with the root x in the denominator there, and we're just left with minus root x plus h. On the bottom, we're not going to do anything fancy on the bottom. Our end goal here eventually is to be able to cancel the h in the bottom. Okay, when you do get to this problem in a calculus class, you're going to want to plug in 0 for h, and we can't have h as a factor of the denominator. All right, that's our kind of our goal. All right. Now, the next step is where we're going to rationalize the numerator. Okay, I have a binomial here in the numerator that involves square roots. I want to rationalize that, again, effectively so that I can factor out an h. The conjugate of the numerator is root x plus root x plus h. And we're going to multiply on top and bottom by that conjugate. So here's where we're using our conjugate business. On top, when you FOIL out the top, or however you get the top done, whether you've mastered the art of multiplying by conjugates and using that product formula, or if you need to slowly FOIL it out, that's fine too. Okay, but you should get x minus x plus h once all is said and done. On the bottom, we are once again not going to do anything super fancy. We're just going to leave this root x times root x plus h times the new bit that we just multiplied by there, root x plus h. On the top, when we simplify the top, we have negative h. On the bottom, we have the same denominator on the bottom, and now we can see that we're going to be able to cancel that h in the denominator. Again, that was the ultimate goal. It's not going to be clear why that's the goal until you get there in your calculus course, but that's the ultimate goal, is to be able to cancel this h. I'm going to pull the minus sign out front. When I cancel the h's, there's a common factor of h in the numerator and the denominator. And we're just left with root x times root x plus h times root x plus h. And I'll go ahead and let your calculus teacher show you how this is going to end up finishing up. Again, this is some algebra that you need to do in the context of a larger problem, but if we're being honest, this is the most challenging part of that problem. Okay, those are the examples that I wanted to show you. If you have any questions about rationalizing denominators when you have these square root binomials, please don't hesitate to ask in class, or ask me over Ivy Learn, or ask your teacher on WebAssign. Thanks for watching.